right, the final thing we need to talk about in section 1.1 is unit analysis. This is something we'll see from time to time throughout the course, but it's really applicable in other areas too, like your chemistry courses or your physics courses, where you have to convert one measurement to another. And so this will be handy for any of those sorts of topics. But again, we'll see that quite a bit in this course as well. An example might be a car engine. Okay, so a car engine, you get your RPMs on your dashboard. And so let's say your car was running at 4,200 RPMs. Okay, so we'll say car engine 4,200 RPMs. Now an RPM, the unit there is a revolution per minute. Okay, so RPM means revolutions per minute. Okay, now it's going to be important to know that, or some of these other abbreviations like miles per hour, mph, and stuff like that. So you're going to want to know some of these, what these units are. So if we've got revolutions per minute, and let's say we wanted to know how many degrees would be turned through in 5 seconds. Okay, so how many degrees in 5 seconds? Okay, so to find that answer, we need to do some conversions. We first need to do a conversion from minutes to seconds. We also need to do a conversion from revolutions to degrees. So there's quite a bit of work involved here. And the final answer is going to be just in degrees. It's not actually going to have a rate associated to it. The first thing to keep in mind is when you see the word per, that represents a division, okay, or a fraction. So the word per is important here. It represents division or a fraction. And as with any rate, the units that come first before the per are what goes on top of the fraction, and whatever comes after goes on the bottom. Okay, so if I were to convert this, I would start with the 4,200 revolutions, and I'm going to abbreviate that REV. That's going to be my numerator, okay, in the fraction. The denominator is going to be the minutes. Well, it's per minute, per 1 minute, so it's 1. Okay. I'm always going to keep the units attached to the numbers. So 4,200 revolutions per minute is 42 revolutions over 1 minute, in 1 minute. Okay. Now, as with any fractions, if you have a factor on top and a factor on the bottom that are the same, you can cancel them. Well, this, in some sense, you can also cancel units out, okay? It's a little bit sloppy, but that's how we're going to think of it. And so if I were to multiply, if I wanted to convert the minutes into seconds, you could convert by multiplying by a fraction that has both minutes and seconds in it. So of course we know that 1 minute equals 60 seconds, so we can create a fraction that has both 1 minute and 60 seconds in it. Okay. Now the combination will, because they're equal, will be 1. Okay, I'll show you that in just a second. So let's take 1 minute and 60 seconds. We know they're equal to each other, so when you divide them, they equal 1. The fraction equals 1. And if you multiply any quantity by 1, you haven't changed the quantity, right? But we have changed the units. The minutes here will end up canceling out. And because the minutes cancel out, now it's kind of weird, but essentially if you have, in any fraction, if you have the same factor on top as you do on the bottom, they cancel. We can kind of do that with units. It's a little bit messy or sloppy, but that's how we're going to think about it. So minutes on top and bottom cancel out, and we're left with revolutions per second. But I don't really want revolutions per second, I want degrees. So I've got to convert revolutions to degrees. I know that in a full circle, that's one revolution, there are 360 degrees. So I'm going to put those together. Now the revolutions need to cancel out, so I need to put those in the bottom. That's one revolution in 360 degrees. Okay, so again, the revolutions now, one on top, one on the bottom, will cancel out, and essentially I'm left with degrees per second. My final answer though shouldn't be in degrees per second, it should just be in degrees, so I need to cancel out the seconds by using the number of seconds given in the problem. And so I'm going to need one more fraction here. I'm going to multiply by simply that 5 seconds. Okay, now I could make it a fraction, just put it over 1. I don't need another unit because it's not a rate, it's just a fixed number or fixed unit. Okay, so when I cancel out all of the units, the seconds here will cancel out. All I'm left with is degrees. Everything else has been canceled. And that's what I'm looking for, is degrees. So now I go through this calculation. Anything on top I got to multiply together, anything on the bottom I have to divide out. But there's a couple of these that will cancel nicely, so maybe I just do this quickly. 360 over 60 is 6. So I could cancel this with this, and I get 6, right? So 60 goes into this 6 times, 60 goes into this once. And so that makes the arithmetic a little bit easier. Now I have all ones in the bottom, so I don't have to really divide. I just multiply. 6 times 5 I know is 30. 30 times 4200, calculator again, 30 times 4200 is 126,000. Okay, so this ends up being 126,000 degrees. All right, so essentially, if you have a 4,200 RPM engine, or an engine running at 4,200 RPM, and it runs for 5 seconds, it would be going through 126,000 degrees in that 5-second period. Okay. All right. So that should cover everything from section 1.1. Lots of definitions, lots of neat little arithmetic examples, conversions, stuff like that. So